In session number 2, what we are going to do is we are going to solve some more problems of the same exercise, exercise 8K. Let's go to question number 21. Exercise 8K, question number 21. Okay, the question is y is equal to root x. Question is y is equal to root x. This is 1 second. This is 20. Sorry. Y is equal to x raised to x raised to x raised to x infinite number of times. Okay, so this kind of problems we'll start with. Okay, now just observe this part which I'm highlighting. This part. So this green colored part. Just observe this part. Can someone tell me the value of this part? What is this part? X raised to x raised to x raised to infinity. The one which I've highlighted in green. So only if you observe this part, isn't it y? Isn't it y? Just if you can give me the response, it will be good. Okay, so x raised to x raised to x up to infinity is nothing but y. So I'm just replacing the power with y. Okay, right? So this is what I was speaking. Just ignore this part. Just ignore this part. Just look at the green colored part. The green colored part is y. So ignore the green, the part which is down, which I've uh, scribbled. Okay, the green colored part is y. Now in the next step, this green colored part is written as y. Fine. Okay, now look at the right hand side. Is base with x and power with x? Yes. Base is with x because there is x term. Power is with x because y is a function of x. This we have discussed. So whenever base is with x and power is with x, we'll take log on both the sides. We'll take log on both the sides. Now this y can come ahead over here as per the property log a raised to b. So this is y log x. Okay. Now once we are done with this, we'll derivate this further with respect to x. Okay, we'll derivate this with respect to x. The left hand side derivative is with respect to x, that is 1 upon y dy dx of y along with chain rule. Right hand side will be product. Okay, so 1 upon y dy dx of y is equal to v derivative of u log x derivative of y plus y derivative of log x. Log x dy dx of y plus y dy dx of log x. Okay, this y we are supposed to shift on the right hand side, that will do. This is y log x dy by dx. Okay, this is dy by dx and y into 1 upon x. Log x derivative is 1 upon x. Now multiply y within the bracket. Within this box bracket, you have to multiply y. So dy by dx is equal to y log x dy by dx plus y square upon x. Y into y will be y square upon x. Okay. So after this particular step, can someone suggest what are we supposed to do? So what we are going to do is we are going to take the dy by dx terms together. Correct. So this term and this term we are going to keep it together. So this term will be shifted on the left hand side. So dy by dx minus y log x dy by dx is equal to y square by x. Now take dy by dx common. 1 minus y log x is equal to y square by x and cross multiply. Dy by dx is equal to y square x into 1 minus y log x into 1 minus y log x. Okay. If you observe question number 24, along with this problem, question number 24 is also covered up. It's the same problem. There is no difference between the two problems. Okay. So if this problem is clear, then question number 24 is also covered up. So let me know if I have to start with the next problem. I'll be solving question number 22 and question number 23 right now. Okay. But then priorly, just take a look at question number 24 from your textbook. It is exactly the same. Question number 24 is done. Let's go back to question number 22. Y is equal to root x raised to root x raised to root x, and this will happen infinite number of times. Okay. Now I will highlight this particular part. Okay. So what is the green colored part? Anyone? So what is the green colored part? The green colored part is y. So y is equal to root x raised to y. Now root x is written as x raised to half raised to y. Root x is x raised to half raised to y. So x raised to y upon 2. Half into y is y upon 2. Okay. Now we got y is equal to x raised to y upon 2. Something like this. Okay. Now base is with x. Look at the right hand side. Base is with x and power is also with x. So taking log on both the sides. Log y is equal to log x raised to y by 2, which is equal to y by 2 will come ahead. Log e raised to b formula log x. Okay. So again we are going to differentiate with respect to x. We are going to differentiate this with respect to x. So the left hand side will be 1 upon y d by dx of y, and the right hand side will be mu into v rule. That is your product rule. So 1 upon y d by dx of y is equal to log x d by dx of y upon 2 plus y upon 2 d by dx of log x. Shift y on the other side. Dy by dx is equal to y log x d by dx of y upon 2. So upon 2, that half will go outside and we'll have d by dx of y. Okay. And d by dx of log x is 1 upon x. This half went outside, d by dx of y. So dy by dx is equal to y log x upon 2 multiply y within the bracket, and this dy by dx of y will become dy by dx plus y square upon 2x, y within the bracket Okay, and multiply y with both the terms. After this particular step, what I'm going to do is I'm going to group dy by dx terms together. So this term I'm going to shift on the left hand side, and it will be minus log x y log x upon 2 dy by dx. When we shift that term on the left hand side, it will be negative. So dy by dx minus y log x upon 2 dy by dx is equal to y square upon 2x. Now take dy by dx term common. 1 minus y log x upon 2 is equal to y square upon 2x. Take LCM within the box bracket first before cross multiplying. So this 2 went up over here, y square upon 2x. Okay, now just cross multiply. 2 will be shifted over here. This entire term will be shifted down on the right hand side. Okay, yes, see this previous slide. Okay, and the next slide. So cross multiplication, I leave it up to you. You can do the cross multiplication part. And once you cross multiply, the 2's will get cancelled. This 2 and this 2 will get cancelled. Okay. So next 2-3 steps, I leave it up to you. Okay. Let us go to the next problem, that is question number 23. Question number 23. Okay. Yeah. So the question is y is equal to a raised to x raised to a raised to x. Okay. So this is going to happen infinite number of times. Infinite number of times. Now look at the part that I am highlighting. Okay. Look at this part. Look at this part. So this part technically it is y. Y is equal to a raised to x raised to y. Okay. Fine. See now base is not with x, but then power is with x. The base is not with x, but then power is with x. Right? So no need of taking log as such. You can use compare this situation with a raised to x formula. But then too, there are so many powers in the problem, so I will prefer taking log in the problem. A raised to x raised to y. Okay. Fine. Then This is the value and this is the power. A raised to x the whole raised to y. So take this y ahead. Log y is equal to y log a raised to x. Okay. Now you can take this value also ahead. This x value also can go ahead now because it is log a raised to b situation once again. Fine. So this will be x into y log a. Okay. So I repeat, this part is taken as y. Okay. Then I have taken log on both the sides. This y came ahead. This is a and this is b. This is a. This is b. So log a raised to b is b log a. Fine. Then here also this situation is a raised to b log a raised to b. So b log a. X will go ahead. So we are left with this now. Now we'll derive this with respect to x. Left hand side is very clear. 1 upon y d by dx of y. Right hand side. Log a being a constant will go outside. Log a being a constant will go outside and d by dx of x into y. Product rule will be applied. But then log a being a constant will go outside. So 1 upon y d by dx of y. Log a outside. Y d by dx of x plus x d by dx of y. So for xy I have applied u into v. So dy by dx, send y on the other side. Y log a, y into 1 plus x dy by dx. Okay, dy by dx of x is 1, dy by dx of y is dy by dx. Multiply y log a within the bracket. So y square log a plus xy log a dy by dx. So I'm multiplying y with both the terms. After this step, you know what you're supposed to do. You're going to group these two terms. Okay, those are dy by dx term. So group it. So this particular term will go on the left hand side and it will be negative. Okay, so dy by dx minus xy log a dy by dx equal to y square log a. Take dy by dx common. 1 minus xy log a is equal to y square log a and dy by dx y square log a 1 minus xy log a. This is your final answer. I'll show you the previous slide. See, okay. Then group the dy by dx terms together and this. Okay, so should I take you to the next problem? I'll be solving question number 25 right now. 25 and 27. 25 and 27. Okay. So let's go to question number 25. I'm erasing all the slides. Yeah. So question number 25. X raised to y plus y raised to x is equal to c. X raised to y plus y raised to x is equal to c. Okay. Now this is base with x and power with x, x raised to y. This is also base with x and power with x. But then we cannot take log at this particular point of time. Whenever the problem has base with x and power with x, we are supposed to take log. But then in this problem, we cannot really take log. I'll tell you why. Because if we take log x raised to y plus y raised to x is equal to log c. Okay, we cannot apply any log property on the left hand side. We cannot apply any log property on the left hand side. Okay, because there is nothing called as log a plus b. There is nothing called as log a plus b. Right? So, what we are going to do, let the first term be u and the second term be v, which is equal to c. The first term let be u, second term let be v. Now differentiate this with respect to x. d by dx of u is du by dx. d by dx of u is dv by dx. d by dx of c is 0. C is a constant. But u and v are not constants. U and v are functions of x. This is equation number 1. Now individually we are going to calculate this. Individually we'll calculate both the terms. Now if we are supposed to calculate du by dx, our starting point should be u. Our starting point should be u. Okay. So I'll start with u. U is equal to x raised to y. Now we have to find out du by dx. Differentiating with respect to x and with the sides. But then now look at the term on the right hand side. It's base with x and power with x. So we'll take log on both the sides. So log u is equal to y into log x. Now derivate this. Derivate this with respect to x. Okay. So this is 1 upon u d by dx of u and product rule on the right hand side. Log x d by dx of y plus y d by dx of log x. Shift u on the other side. U log x dy by dx plus y into 1 upon x. How did you get u as x raised to y? Because I assumed it. U is equal to x raised to y. Okay. Fine. Till here, I think things are pretty clear. The next step would be to multiply u with the box bracket. Multiply u with the box bracket. Okay. And remember, u is not a constant. U is a function of x. What is the value of u? U is assumed to be x raised to y. U is not a constant. So next step, du by dx is equal to u into log x dy by dx plus u into y upon x. So we got the value of du by dx. We needed this value, du by dx. So we got the value of du by dx. Now our starting point should be v because we require dv by dx. Okay, so v is equal to y raised to x. We assume v as y raised to x. Okay, taking log on both the sides because the right hand side is base with x and power with x. Right hand side is base with x and power with x. So log v is equal to x log y. Log v is equal to x log y. Okay. Now differentiate this with respect to x. Differentiate this with respect to x. Left hand side will be 1 upon v d by dx of v. 1 upon v d by dx of v. Right hand side will be product v. Let's start. 1 upon v d by dx of v. Right hand side product v. Log y d by dx of x plus x d by dx of log y. So dv by dx is equal to v log y into 1 plus x derivative of log y 1 upon y d by dx of y. Then multiply v within the bracket dv by dx is equal to v log y plus vx upon y dy by dx. Okay, so we got the value of dv by dx. We got the value of dv by dx. So once you get the value of dv by dx and du by dx, put dv by dx and du by dx values that we have got in equation number 1. So let's go back to equation number 1. We have these two values now, du by dx and dv by dx. So right from 1 du by dx plus dv by dx equal to 0. Okay, put the value of du by dx. What is the value of du by dx? U log x dy by dx plus uy upon x. U log x du by dx plus uy upon x plus dv by dx. dv by dx value we have it over here. V log y plus vx upon y dy by dx. So v log y plus vy upon x dy by dx equal to 0. Now group the dy by dx terms together. This is dy by dx, sorry. Okay, so dy by dx u log x plus vy upon x equal to the non dy by dx terms. These two are non dy by dx terms, so shift them on the right hand side. So minus qy upon x minus v log y. Okay, now take LCM in the left hand side as well as right hand side. Take LCM. So dy by dx into ux plus, I'm taking LCM, ux log x plus vy upon x, ux log x plus vy upon x, and right hand side minus uy minus vx log y, minus uy minus vx log y upon x. So this x is getting cancelled on both the sides now. Okay, now cross multiply. dy by dx equal to minus uy minus vx log x upon ux log x plus vy. And the last step, re-substitute the values of u and v. U is nothing but x raised to y, and v is y raised to x. X raised to y into y raised to x into x upon log x upon x raised to y into x log x plus y raised to x into y. Okay, that is your final answer. Moreover, what you can do is you can just group these two terms. This can be written as y raised x raised to y plus 1, and this term can be written as y raised to x plus 1. Okay, this is the final solution. If you are having any doubts, any queries, please ask. Yes, I'll go back to the previous slide. See, I've taken LCM after the last step and then cross multiply. I'll show the problem entirely once again. See, this is the first slide. This is the second one. Individually, u and v have solved using logarithmic differentiation. This is the third slide. After completing du by dx, I started with v and then I'll find out dv by dx. For v also, I'm using logarithmic differentiation. This is the fourth slide. I calculated the value of dv by dx. Okay. Now, once I calculate du by dx and dv by dx, I'll put this in equation number 1. I'll put this in equation number 1. So this is the next slide. Okay. Fine. Then take LCM and cross multiply. Vx upon y. Where is Vx upon y? Just let me check. Vx upon y. Okay, I just committed some copying mistake. Vx upon y. let me make those changes. Sorry. Now is it correct? Any other discrepancies there? No, right? So it will be uy log x, uy log x upon y. Okay. So this will be y over here. Okay. Now this will be multiplied with x, and this will be multiplied with y. Right? And this will be y. This will be multiplied with y, and this will be multiplied with x. That's it. Is it fine now? Just let me check once again. Okay, this is I think that's it. I don't think so any other uh, copying error has been done. Fine. I'll be starting with the next problem right now. That is question number 20. Just a second. Yeah, question number 27. Okay, so differentiate sin x raised to x with respect to x square. Question number 27. Differentiate sin x raised to x with respect to x square. So let the first term be u, second term be v. So it will be rewritten as differentiate u with respect to v. Okay. Now guys, they are asking du by dv. The meaning of differentiate u with respect to v is du by dv. Okay, so they are asking you du by dv. Now what are u and v? They are functions of anyone? U and v, they are functions of x. U is in terms of x, v is in terms of x. U and v are functions of x. Okay, so du by dv. See, u is not a function of v, but then u is a function of x, v is a function of x. So du by dv is equal to du upon dx and dv upon dx. They are asking you du by dv, right? Since both are functions of x, we'll write it as du by dx upon dv by dx. Equation number 1. Equation number 1. Now what I'm going to do is I'm going to calculate du by dx and dv by dx separately. I'm going to calculate du by dx and dv by dx separately. So I'll start with u. U is equal to sin x the whole raised to x, base with x and power with x on the left hand right hand side. So taking log on both the sides. So log u x log sin x. So this I'm going to differentiate this particular part. So left hand side derivative is 1 upon u d by dx of u. Right hand side is product rule, log sin x d by dx of x plus x d by dx of log sin x. Okay, fine. I'll use the product rule on the right hand side. Now send this u on the right hand side and put a bracket after it. So du by dx is equal to u, put a bracket, log sin x into 1 plus x d by dx of log sin x, that is 1 upon sin x d by dx of sin x. This is the chain rule. Derivative of log sin x is 1 upon sin x d by dx of sin x. Okay, so du by dx, final answer, u log sin x plus x upon sin x into cos x. Now cos x upon sin x can be written as cot x, log sin x plus x cot x. We got the value of du by dx. In equation number 1 which you have copied, there are two things that we require. We require du by dx, we require dv by dx. Okay, so du by dx we have calculated. Now let's go to v. Why we are supposed to go to v now? Because we are supposed to calculate dv by dx also. Fine, so let's go to v. V is equal to, let me check what is v. V is x square. That's a very simple term. No need of taking log and all over here. Direct derivative. dv by dx is equal to d by dx of x square. dv by dx is equal to 2x. That's it. It was very plain and simple. Now go back to equation number 1. Okay. From 1, du by dv. Now what is du by dx? du by dx is u log sin x plus x cot x. u into log sin x plus x cot x upon v. V is 2x. And the last step, du by dv. Replace u with sin x raised to x into the box bracket which we have got upon 2x. Into the box bracket which we have got upon 2x. So that's the solution for this problem. Please let me know if you are having any doubts in this problem. It was a different format, this and the previous problem. Previous problem there was a plus sign in between, so we didn't take log initially. This problem, the format is totally different. Okay, so take the first term as u, take the second term as v, then it becomes du by dv. Now since both the terms are functions of x, so du upon dv is equal to du upon dx upon dv by dx. Just give me a feedback whether you have understood this problem or not. Okay, fine. So let's go to the next problem, and probably this should be the last problem for the day. Okay, that is question number 20 of the same exercise. Fine. question number 20. I hope you are referring it. So question number 20 says x raised to m plus y raised to n is equal to x plus y raised to m plus n. Okay. See, now there are multiple terms with powers and multiplication also. The rule was multiple terms with powers or multiplication and division or division. Okay, but then multiplication is there. X raised to m into y raised to n. Both the terms are having powers. Right hand side term is also having power. So that's the reason why I'll apply log on both the sides. So this is the second instance when we use log on both the sides. When there are multiple terms with powers. Left hand side, let this be a, let this be b. What is log a into b? Log a into b is log a plus log b. So log x raised to m plus log y raised to m. Right hand side, log a the whole raised to b. So b log a. Right hand side is b log a. Okay. Now this is m log x plus n log y, m plus n log x plus y, m plus n log x plus y. Okay, so this m n I've taken ahead. Now I don't think so any other log property is left to apply over here. Now we are going to derivate this entire term. We are going to derivate this entire term. M is a constant. Derivative of log x is 1 upon x. N is a constant. Derivative of log y is 1 upon y. M plus n is a constant. Derivative of log x plus y is 1 upon x plus y d by dx of x plus y. For this your chain rule should be in place. So m into 1 by x plus n into 1 upon y d by dx of y, m plus n 1 upon x plus y d by dx of x plus y. Okay, fine. So look at the last step written over here. I have derivated that entire step. M into 1 by x, n into 1 upon y. But then when you derivate log y, chain rule will also come because we are differentiating with respect to x. And for log x plus y also I am using chain rule because in place of x it is x plus y. So both the places I'll have to use chain rule. Okay, that's how I will get the next step. Should I go to the next slide? Okay, so I hope you have copied this. So this is the next step. Achha, this box bracket is also very important because there are multiple terms outside the bracket. Fine. So m upon x plus n upon y dy by dx is equal to m plus n upon x plus y. Dy dx of x is 1 and dy dx of y is dy by dx. Okay. So m upon x, n upon y dy by dx equal to multiply this with both the terms. M plus n upon x plus y plus m plus n upon x plus y dy by dx. Okay. So I'm multiplying m plus n upon x plus y to both the terms. Let me know if you are having any queries. Okay, so after this, what I'm going to do is I'm going to group the dy by dx terms. N upon y dy by dx minus m plus n upon x plus y dy by dx. N upon y dy by dx minus m plus n x plus y dy by dx. And I will take the non dy by dx terms and keep it on the right hand side. So this green colored terms I'll keep it on the right hand side. So m plus n upon x plus y minus n upon x. N plus n upon x plus y minus n upon x minus m upon x. Sorry. Take dy by dx common. N upon y minus m plus n upon x plus y. M plus n x plus y minus m upon x. So dy by dx, take LCM. Okay, right? So cancel x plus y on both the sides because there is multiplication between the terms. Okay, in these terms, I'll just open the bracket in the next step and let us observe what is happening after that. Take your time to copy. If any doubts, you can please ask. Yeah, so I'm going to simplify the brackets now. So this will be nx plus ny minus my minus ny. Okay, so dy by dx nx plus my minus ny minus my minus ny minus my minus ny upon y. Right hand side mx, this is x, mx plus nx minus mx minus my. Mx plus nx minus my minus n upon x. So some terms are getting cancelled. My gone. Okay, I think I made some copying error. Mx plus nx minus nx. So this is x over here. Okay, so here also mx will get cancelled. Now dy by dx nx minus ny upon y equal to nx minus ny upon x. Okay, so these two terms will get cancelled. It's not ny minus ny, it is nx minus ny. See, I'll just go to the previous slide. Okay, so we'll just understand this once again. It is nx, I'm discussing this part, nx plus ny, let me check, nx plus ny, uh, yes, this is nx plus ny. Sorry, I had to turn the page so this errors happen. Now is it fine? Okay, so ny gets cancelled, so it is nx minus my. Okay, and right hand side I'll just check mx plus nx, mx plus nx minus mx minus my. So here also I made a error in copy, minus my. Okay, so nx minus my. Fine. So now what will happen is this term and this term will get cancelled. It's the same term and there is multiplication. So just cross multiply now and get the answer. dy by dx is equal to y upon x. This y is going on the left hand side, right hand side at the top. Okay. So hence proved. This is what is required. If you check the proof from the textbook, this is what is required. Now before winding up, I would like to solve one more problem so that the last lecture on logarithmic differentiation is not quite a big one. Okay. Let's go to 17th question. Exercise 8K, question number 17. Fine. 17 sub question 1. So y is equal to cos x raised to x. Y is equal to cos x raised to x. Okay. Now this base with x and power with x, it is encapsulated for cos. So if we take log initially, it won't be of much help because it's the angle over here. So instead I'll derive it first. Okay. Even if you take log at the beginning, it won't help us, right? Because if I get something like this, log cos x raised to x, then here we'll have to apply chain rule, right? So instead I'll derive this first and then maybe possibly I'll think of applying log. Let's see. Okay, the derivative of cos is minus sign into d by dx of, apply chain rule and tell me what should be the part of this round bracket. The left hand side will be dy by dx. What is the part of this round bracket? Come on, tell me. Correct. Some students are replying. You compare this with cos x. Your x is x raised to x. So dy dx of x raised to x. Now this is equation number 1. This is equation number 1. Why I'm marking this as equation number 1 is because we cannot apply any formula over here. X raised to n or e raised to x or a raised to x. This formula are not applicable over here. That's why I have to apply chain rule. I have to apply logarithmic differentiation. So I'll assume x raised to x as u. I'll write let u is equal to x raised to x. Now taking log on both the sides because it is function base with x and power with x. So log u is equal to x log x. Differentiate this with respect to x. So 1 upon u d by dx of u equal to product rule on the right hand side. log x dy dx of x plus x dy dx of log x dy dx of log x. Fine. Now shift this u on the other side. Shift this u on the other side. So du by dx is equal to u into log x into 1 plus x into 1 upon x. Log x into 1 plus x into 1 upon x. Okay. So du by dx is equal to u log x plus 1. Now replace the value of u, but then this time replace the value of u on the left hand side as well. Okay. So dy dx of replace u with x raised to x. Do it on the left hand side as well. Okay. Now look at equation number 1. If you have written equation number 1 clearly, there is this particular part. This part. There is this particular part. So replace that part with this. Replace that part with this. Okay. Yeah. So the next step will be from 1 dy by dx is equal to minus sine x raised to x into x raised to x log x plus 1. So I'll tell you what I've done. We calculated this part, right? So here we are resubstituting the value of dy dx of x raised to x. Remaining parts will remain the same. Okay. So this is dy dx of, this part is dy dx of x raised to x. That I have substituted from the previous slide. From here. Since we got the value of it. So 17 second sub question, you can take it for self study. And I think today's session will have to wind up over here itself. There is one more session which is left on logarithmic differentiation that will be taken in the next slot. Yeah, thank you. Bye.